We're going to start 2.1, and chapter 2 is about the Euclidean coordinate system. It means the rectangular coordinate system, graphing stuff like lines and circles and such. So we're going to start out, take the average of two indicated numbers. Now this is something you should know from previous classes. We're going to just express here what this means graphically. Okay. So over here you're going to have -7, and 6/7 is a little bit smaller than 1. 7/7 would be equal to 1, right? So the average is basically what's in between here. What is the point that's in between here? That's what an average is. The way we find the average is we add the numbers together. We'll call it x1 and x2, and then we divide by 2. So I'm going to write this by, I'm going to take out the 1/2 for now. And we can also think of this as x1 plus x2. This is going to be 6/7. Now the -7 is actually 49/7, right? We need a common denominator here so we can add them, and it's going to be 49/7. Now we can add these together. This is -43/7, and this is -43. We can't really simplify anything here. Think of prime number, prime number, prime number. So we're left with this. This is 14 goes into 40. Now you don't have to do any more than this. At this point we're done. But 14 goes into 42 3 times. So this is like -3 and 1/14. So somewhere, -3 would be right here. It's a little bit to the left of that. So it kind of makes sense. That's where it should be. But keep in mind that it's the midpoint also. That's the original one. -43 14ths. Okay. Simplify radicals. This is going to be important because when we do the distance formula, we're going to have radicals. Okay. Simplify this radical. So here we're going to deal with each one first. So 35 squared is, I'll just kind of do that on the side here. 35 times 35 is 5, 217, and then this is going to be 105, 5, 2, 2, 1. So this is going to become, now remember you can use your calculator and all this, and actually I have a calculator here, so why not use it. So just to double check, 35 times 35 is that. Now 7 squared is 49, right? So plus 49 is 1274. So this is square root of 125 plus 49 equals the square root of 1274. Now, how do we simplify this? Let's see, it wants an exact answer, okay? So now we're going to have to factor 1274. And so we just start with basics. We start with, to divide by 2, it means it's even. If it's divisible by 3, it means that the digits add up to a multiple of 3. And 5 is easy because the last number is either 0 or 5. So here it's clearly 2. Like I said, we can still use our calculator here. So 1274 divided by 2 is 637. And this is not divisible by 2 because it's not even. It's not divisible by 3 because 9 plus 7 is 16, which is not divisible by 3. It's not divisible by 5. Is it divisible by 7? Well, it's only one way to find out. Divisible by 7. That happens to be, so we just tried it, right? So 7. You just try different numbers, and we got 91. 91, is that prime? I think it might be divisible by 13. Yeah, so 7 goes into it again. We're left with 13. Now 13 is a prime number. Now this is our prime factorization here. So this is equal to the square root of 2 times 7 times 7 times 13. If you recall our method here, draw 2 squares and the square root. There's not enough 2's to go around, so the 2's are out. There's enough 7's to go here. The 13 is not enough to go around. So our answer here is this right here. 7 radical 26. Plot ordered pairs. Now here we're going to start using the graphing feature here. Plot each ordered pair in the Cartesian plane and state in which quadrant or axis it lies. Plot the ordered pair in the Cartesian plane 2, -3. So 2 is over here, -3 is down here. Let's see, how do we do this? Just drag it over, 2, -3. The way the quadrants work is this is 1, 2, 3, 4. Okay? So 2, -3 is in quadrant 4 because it's 1, 2, 3, 4. Next we're going to plot -3 halves. So -3 halves is like -1.5. So this is going to go over here to -1.5 and up to 1. This is in quadrant 1, 2. Plot radical 5, 2 pi. Now radical 5, you can put in your calculator, it's between 2 and 3 because square root of 4 is 2 and square root of 9 is 3. So this is about 2 point something. 2 pi is 6.2. I guess I've used your calculator here. So this is about 2 and 6. And only this one looks like that. We can make it bigger. So actually here it's measured by pi's. So here we have 2 radical 5 is around here, and notice this is counting by pi, so this would be 1, 2, 3 up to 10 pi, so this is 2 pi right here. So it'd be this one. Plot the 7 halves is 3.5. 0 means we stay there. This is the x-axis, this is the y-axis. So back to, I forgot to do this one. This is quadrant 1. And this one is on the x-axis. Plot the ordered pair 0, 0. And that is the origin. 0, 0 is the origin here. Graph y equals 12x squared. Now, what we want to notice here is that this is a parabola, and it's going to open upwards because the leading coefficient is positive. So the x squared tells you it's parabola, the 12 tells you it opens upwards. Now, only one of these is a parabola that opens upwards. This one is not a function, it's a parabola that opens sideways. This is a cubic, this is a line, so it has to be this. And if you really, really wanted to, you could graph it, and if you went up to 1, the point 12 would, this would be the point 112. So, but we don't need to even do that. I mean, these are clearly different graphs, so there's only one that's a parabola that opens upwards. Find the midpoint. Now this is where our knowledge of the averages comes in again. And now this is like a two-dimensional average. Where's the midpoint between 2 points in two-dimensional space? The formula is the same as the average. This is x1, y1, and then this one is going to be x2, y2. So what you do is you just add the x's together, divide by 2, add the y's together, divide by 2. So here we're going to have 5 plus 5, so it's 5 plus 5. And here we have -1, and here we have 2. And this is equal to 10 halves. This is 1 half. 10 halves is 5. 1 half is 1 half. So 5 or 1 halves. 5 1 half. Notice it says simplify your answer, so that's why you need to put 5 and not 10 halves. And find the distance between 2 points. Okay. So the distance formula is actually a Pythagorean theorem. If you think about it, you have 2 points, wherever they may be. And the distance between them, if you think about it, you can make a right triangle here. And this distance here, if this is x1 and this is x2, and if this is y1, this is y2, then the distance between x1, y1 and x2, y2 is this distance here. If we had whatever this was, if we called it A and we called this B, this distance would be C. C squared is A squared plus B squared from the Pythagorean theorem. But A is just x2 minus x1. It's the distance between here. So, and B is just y2 minus y1. So what we get is the distance squared. So then you have to just take the square root of both sides. the distance is equal to the square root. A squared is x2 minus x1 squared plus y2 minus y1 squared. Okay, in this case it's going to be square root of x2 is negative 1 minus 4 squared plus y2 is negative 1, not comma, but minus 1 squared. This is 5 squared. Now, you can keep the negatives, but remember when you square, everything's going to become positive. Negative 5 squared is 25 plus, not plus 9, plus, I was adding it in advance. It's plus 4 is the square root of 29. 29 is a prime number, so you can't do anything with that. Radical 29. And that is 2.1.